In this first group of problems that we're going to be doing today, we're going to see situations where they ask the questions, how long does it take to complete a job? So say, for example, you might be painting all the fences in your neighborhood, just say, for example, and you can do a whole fence in 10 hours, and you have a friend that can also do a whole fence in 10 hours. So, but you're kind of bored and you'd like to work together. So say you work together to paint a fence. How long do you think it's going to take to complete it? Well, it kind of makes sense if you both do it in 10 hours that it's going to take you half as much time, which would be 5 hours to complete the job. But now what happens if you paint a little bit faster than your friend and you say paint it in 10 hours and your friend might take 12 hours? How long then might it take you to do it working together? And those are the kind of questions we're going to ask. Now we're going to use our charts again to do this, and I know that you may see some shortcuts on this, but I'm going to use a chart that will fit in a whole lot of different situations. So our rate in this is going to be how many jobs can you do in an hour? So that will be our rate. So I'm going to stop this. So pause, read this question, and draw yourself a chart. All right, well, that was a little bit tricky, but hopefully you got the general idea on this. I did want to have the rate of job per hour. How many jobs can you do in how many hours? So then I'm going to multiply, of course, by the denominator over here, so times hours. And this, I'm going to add a little bit of a word there, and this is going to be their hours together. And when I multiply these two things, it's going to give you the part of the job that each person does. So on this particular problem, what is a job? So we need to think about that. So in this problem, a job is going to be washing the elephants. So that is my complete job that I'm going to do right there. It says Zoe, so we've got Zoe, who has a way with elephants, can wash the elephants in 4 hours. So she can do one job in 4 hours. So you see how that matches this unit here, one job in 4 hours. And Nick, who likes to go sailing, can do one job, the same job, but it takes him 6 hours to do it. Now we don't know. It says how long would it take them to wash the elephants if they work together? So we don't know how many hours they're going to use working together. So that will be their X. And since they're going to work together, they start at the same time, end at the same time, they're both going to be working the same number of hours as each other does. So then, as usual, we're going to multiply our first two columns, and that's going to give me X over 4 and X over 6. Now the question is, how long will it take them to wash the elephants? We want to know how long will it take them to complete one job. So these two things are going to add up to 1. And my equation then is going to be X over 4 plus X over 6 is equal to 1. So to solve our rational equation, we're going to multiply by the common denominator, which is 12. And that will give us 3x plus 2x is equal, don't forget to multiply 12 times 1 and get 12. So I get 5x is equal to 12. Divide both sides by 5 and I get x is equal to 12/5, which is 2 and 2/5. And our unit up here was hours for that. So 2 and 2/5 hours. And we can change 2/5 of an hour into minutes pretty easily. So 5 will go into 60, 12, and 12 times 2 is 24. So that's 2 hours and 24 minutes. So this next problem, I want you to read it and again, set up a chart. All right, so hopefully you noticed that the job in this situation is mowing a lawn. So that's going to represent that job. And we've got two players. We've got Megan and we've got Kyle. So Kyle can mow a lawn in 2 hours, so he can do one job in 2 hours. And Megan can do one job in 3/2 of an hour. And so I want to do the reciprocal, so divide that, and that becomes 2/3. I want to know how long it takes them to work together. So the number of hours that Kyle works, we know that Kyle's going to start at 10 o'clock, and we'll say that he works for X hours. Megan, though, is going to start at 11 o'clock. She must have wanted to sleep in. So if she starts at 11 o'clock, she's not going to work the full amount of time that Kyle did. In fact, she's going to work one less hour. So when she works, she's going to work same number of hours he does, minus 1. So X minus 1. So if I multiply across, I get X over 2. And when I multiply this, I'm going to get 2 times X minus 1 over 3. And again, we want to know how long it's going to take them to do one job. So I'm going to add. So I'm going to have X over 2 plus, I'll distribute there and get 2X plus 2 over 3 is equal to 1. So we'll need to solve it, multiply through by 6, and we'll get 3X plus, I'm going to cancel and get a 2, so I'm going to get 2 times this, so that's going to be 4X plus 4. I needed to distribute, is equal to, and then 6 times 1 is 6. And so simplify 7X. I'll subtract my 4 from both sides, so subtract 4. And I'll get is equal to 2. Oh, that was a minus, wasn't it? That's a minus. That makes this a minus. That means I'm going to add 4 to both sides and get 10. Sorry about that. This is a minus up here. Maybe I'll do that in a different color. This is minus. So that makes this minus. All right, so then divide both sides, and you get that X is equal to 10/7, which is 1 3/7. So we can say that it takes them 1 3/7 hours. Well, it actually takes Kyle 1 3/7 hours. Little Megan, she just did 3/7 of an hour. But that's not what it asked for. It asked for at what time did they finish. So if Kyle actually started, he's the one that's X, he started at 10 o'clock, then we're going to have 10 o'clock plus 1 3/7 of an hour. So that's going to be 11 something, right? So we need to figure out what 3/7 of an hour. And so if we take 3/7 times 60, we're going to get about 26 minutes. So this is going to be 11 plus 26 minutes, which is going to be 11:26 a.m. So we'll take a minute and switch videos now. So read problem number 3.